All right. So, okay, regression is as you may have learned in the past, it's a way to predict certain behaviors. Okay, so based on a study of certain factors or based on the study of a certain piece of the environment, you think that by observing these variables, you can predict what can happen. Okay, what can happen in another variable at a future time. So that's how regression was initially taught. In our case, we will be using regression to explain the relationship between one variable to another. Whether it is influential or not, okay, whether they exert significant effect or not, and even the direction of that effect or influence, kung positive or negative ba. So that's what we're going to do. And I think before you were taught more on simple regression, like one independent variable and one dependent variable. So that's the easy part. And then but what I'm going to also to show you is not only about simple regression, but also multiple regression. So, Ines, yes. The relation is really more like let's say x relates to y, meaning there's a relation, but you do not know if x causes y. Okay, there's a difference. Okay, there's a difference. So, you can say that okay, x affects y, but you don't know how. It's affects. Basta sinabi mo lang it affects. You know. Okay. There is a tool for that. It's called structural equation modeling, wherein you can safely say that X causes Y. Causal effect, kumbaga, instead of a correlation effect. Yeah, right. The also confusion there would be sometimes your X relates Y or relates to Y or X correlates to Y, but if you turn it around, it might be the case also na Y correlates to X. So, may ganon. Hindi mo pwedeng gawin yon sa causal relationship. Kasi pag sinabi mo X causes Y, but at the same time Y causes X, so ano ba talaga? The whole thing's confused. So that's the difference. Okay? That's the difference. So right now, our assumption is X affects Y. Yeah, done. The regression of this sort. Regression of this sort is more on X affects Y. Okay, X affects Y. Itong regression. In structural equation modeling, it's also a form of regression. Pero medyo may konting pagbabago doon sa formula niya, yung sa mathematical formula ng regression, to say now that X causes Y. Hopefully, we'll have time later, like towards the end of the semester, that I can teach you how to do structural equation. Okay? Yun medyo more on drawing naman siya. Okay. So yeah, so with that, so let's proceed. So assuming we're gonna have these four variables, MCFP, MPPE, MSEFF, and MTRU. The diagram behind me shows that these first three will be the independent variables and MTRU will be the dependent variable. Okay, so nasaan siya? Let's go back to analyze. Okay. And then regression. Notice SPSS has a lot of different regression models. Now, unlike other software, especially like say Stata, in which you can actually input, you have to code your formula itself. What SPSS has is it gives you several options on what kind of regression model that you will be using. Now, of course, each one, okay, Okay, each one of this has a certain assumption regarding what kind of regression you're going to use and what kind, the nature of your data. I'm not sure if it's Stat 101 you were taught concepts like BLUE or OLS or PLS and so all sorts of that. Well, if you took an econometrics course, yung biased linear, something yun yung estimate, something like that, unbiased, blah 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 blah, stuff like that. There's a lot of different things about it. If you're interested to take a PhD, that's the time you'll know about it. So, yon. But for now, we will assume that everything's standard, yeah, everything's normal. So we choose linear regression. Yeah. Kasi diba, pag sinabi mong linear regression, normally it's one straight line. Right? It's one straight line. So, this is linear regression. So, welcome to linear regression now. Now, we are not going to be focusing our attention here sa mga CFP1, CFP2s, so on and so forth. Unless you want to do a regression on a item-to-item basis. No? So, we go to the very end of our list and we look at this 4. So, the first box that you see on the right-hand side is the dependent variable. So, you put TRU there. Okay. So, notice when you do regression, you always assume that you have one dependent variable. One dependent variable. Now, here, on the bottom part, you would see the independent variables. So, you can do simple, you can do multiple. The only difference between simple and multiple regression is that for simple linear regression, you have one independent variable. Multiple linear regression, you have, as the word implies, multiple or more than one independent variable. Okay. So, simulan muna natin dun sa alam natin. Simple. So, let's do it one by one. So, if you want to do just simple linear regression, then you put it one by one. So, CFP would be there. Okay. And then, you look at statistics. Okay, let's now try to customize the output by looking at statistics. So, estimates and model fit will be the default there. I would also like you to click on collinearity, diagnostics, then Durbin-Watson. Okay, ano tong mga to? I'll explain in a little bit. Okay. You can also do a plot of it if you want. We're not gonna do that. Options. Okay. We're gonna do that. So, this is it. Okay. And then you click OK. Now, you will see the results of your regression. Okay. Now, the first thing that you would like to look at is the model summary. The model summary will show you your R-square. Okay, and that's our first criteria. The R-square is your model fit. You still remember what R-square is? 182. BA198. It's your model fit. Okay, it's a model fit. What does model fit mean? Okay, it's how well their model fits. Okay, okay, let me put it. I can use two analogy for this. One, think of R-square as your shirt. As your shirt. T-shirt. Or your top. Okay, your top right now. What my professor said was that you want a higher R-square, and that means you want a fitting shirt. But you don't want something that's too fit. Naman din. You don't want so much as a too fit of a shirt. Okay. So imagine your body as the fury or as the framework, your torso, your chest, your shoulders, your arms as the fury, the framework, and the shirt is your data. So you want some fit, but you don't want it too fit na hindi ka naman makahinga, na hindi ka makagalaw. So what does that imply when it comes to R-squared? You want an R square. You want an R square that is greater than 0.10. Okay? That's our first rule of thumb criteria there. But you don't want an R square that is somewhere around 0.7, 0.8, 0.9. Bakit? Kasi parang lumalabas ngayon doon, practically speaking, the relationship is already very obvious. Ba't ka pa nag-test? Obvious na siya. So that, and the same way, diba, you don't want a shirt that's too fit for you na hindi ka na makagalaw, hindi ka makahinga. Kahit sabihin mong naka-Uniqlo, dry fit ka pa, supposedly nakakahinga ka, kahit sabihin mo masikip. Yeah, so that's the first criteria, R squared. Okay. Minimum is 0.10. Okay. So apparently, in our case, bagsak tayo. So because our R squared right now is only 0.019. Yeah, 0.019. So that means we have a poor model fit. Poor model fit. Now, the Durbin-Watson here is a measure of what we call multicollinearity. Okay, multicollinearity. That means, okay, practically speaking, it's just like another quality measure, okay, which can explain why you have a low R squared. Okay. Now, the Durbin-Watson, okay, abbreviated as D-W, should be between 1.5 and 2.5. So we are actually at the higher end of it with 2.1. Okay. So Durbin-Watson is between 1.5 and 2.5. So the second one. Now, notice that in regression, it will also calculate an ANOVA for you, analysis of variance. May F value na nakasama dyan. That's part of it. And the F value should be greater than 4.0. With its corresponding significance value of less than 0.05. So pagdating sa F value, ang titingnan nyo would be this one and yung katabi niyang sig value. Otherwise known as the P value. P value. 0.05. 0.05. Now, what does ANOVA tell you? What does the analysis of variance tell you? We will be touching on ANOVA later, so let me introduce it a little bit. It's like, okay, fine, you want some relation between those two variables, but you don't want them too related, so you want some degree of separation between the two variables in which you are looking at. Yeah. So that's what ANOVA is. It's a testing of the difference between two variables or two groups of data. So these two groups are your concern for privacy and your trust right now. So gusto mo may konting separation din in between. Kahit sabihin mo you are hypothesizing that there might be some relationship, yes, that CFP affects trust, okay, but you also want them separate. Just like in a typical human relationship. Okay, fine, you want to be with that someone majority of the time or like half the time, pero may sarili ka ring buhay. Right? So yun, di ba? So that's being dictated by your F value. Okay, what I just said is being recorded. So as well. So yeah, and it will go into YouTube later. So yeah, so that's the next set of criteria. The last one is your coefficients table. This coefficients table, think of the coefficients table as how do I say it? The details. Okay, the details that describe more the model summary. So you have a model summary. The coefficients table will show you the details of that summary. So what we're going to be looking at will be The standardized coefficient represented by your beta, the T, or what we call the T statistic, the significance. Okay, the significance value here. Now, a typical regression equation will always go like this. You have a constant, right? You have a constant value, and then your beta 1, x1. The standardized coefficient is your beta. Okay? Your beta 1, x1 is the variable. Right. So you can look at this. Okay? You can look at this as the beta of CFP and an x CFP. Right. So yeah. And then y is your TRU. Right? So beta, so again, you're going to look at beta. Beta in itself, walang masyadong criteria dyan. There's not much criteria there. It gives you the direction. Where it's supposed to be, where done. Because remember, I said a while ago, we want to try to explain the direction, whether it's positive or negative. So the beta would tell you how positive it is or how negative it is. Okay, so that's beta. What's more important is the T and the sig. Okay, the T value and its corresponding significance value. So here, the T value, okay, the T value should be greater than 1.96. Okay, should be greater than 1.96. By the way, this can be an absolute value because obviously kung negative yung beta mo, if your beta is negative, then you're expecting that the T value should also be negative. So this is absolute value. Absolute value of T should be greater than 1.96. And again, its corresponding significance, or what we call the P value, should be greater than 0.05. 0.05. What? Greater than or... less than. The significance is less than 0.05. So, in this case, we would see CFP here has a beta of 0.138, a T value of 2.732, and a significance value of 0.007. So, pasok tayo. So, that would mean that for our model, for the first one, for concern for privacy, we have a beta and it's significant. Insignificant. Now, in terms of notation, less than pala, sorry. Yeah, I made a mistake. Sorry. 0.05. This is 0.007. So less than siya yan. Okay. Yeah. Nakakalito siya. Actually, there are 3 levels when it comes to significance, or when you're talking about p-value, there are 3 levels of significance. And this is denoted by the number of asterisks that you put into the value. So, 3 asterisks would mean that the p-value is less than 0.001. 2 asterisks would mean that the p-value is less than 0.01. And then 1 asterisk would mean p-value of 0.05. Okay. So, it's just telling you how significant it is. Very significant. Okay, still significant. All right, somewhat significant. Yeah, still okay. Still significant. Stuff like that. Okay, so if you want to make a notation like this, so if the significance value is 0.007, then you write it as 2 stars like this. Ano na yan? Default na yan. Like, you don't need to report it in an entire table. What you can do is just report the beta, the number, and then indicate how many asterisks you want to put there based on the corresponding significance value. Okay, pag nakita nila yun, okay, it's significant at 0.0. Okay. It's significant at this level. Okay, second level. Okay? Okay, nakuha so far? Yes.
Pero di ba kanina, hindi mo pumasa sa parang criteria natin for R square?
Yeah.
So, hindi nag-fit yung...
Exactly. Yeah. That's another argument. That's one of the arguments. So, even though sabihin mo ganito siya, may values ng ganyan, if you're kasi here's where some of the debate happens as well. Some people, pag sa R square pa lang bumagsak na, rejected kagad. Okay, rejected kagad. But some people would still, let's keep it. Let's try to keep it. But remember, we're using simple regression pala. Okay, so it's really not much of a problem if you're using simple regression. Okay, if using simple regression. So yun lang din yung weakness if you do it by simple regression. Let's try to do it multiple regression. Okay, let's try to okay. So let's see what happens now with the rest. Okay, let's see what happens now with the rest. So, regression, again, linear, in the same way before na as long as you're not clicking reset or as long as you're not closing SPSS, hindi mo na kailangan ulitin lahat to. Okay, so let's see what happens. I say, palitan natin CFP, lagyan natin si PPE. Okay, again, we're still at simple. So, in this case, I notice for MPPE, the R square is greater now. Okay, as in pasok na siya. Okay. And notice that its coefficients, you have 0.370, a significance value of 0.00, which that means, for PPE, 3 star siya, very significant. Good. Okay. Now, see the difference. Because you have a higher beta and you have a more significant value of that beta, it's affecting your R square. It's affecting it. So that's one explanation. Okay, that's one of the many explanations as to why R square is behaving that way. So sometimes, if you do not get a 3-star type of significance, meaning your significance value is less than 0.001, and that's the only independent variable, then your R square suffers. Okay. So yun. Now that you see like a single variable, okay, a single variable here, okay, can already influence a model fit. Bakit? Kasi nga, you have a relatively higher beta, meaning yung degree ng direction, which is positive or negative, yung degree of direction, and the significance value. One of the ways you can also imagine the difference between a beta and the significance value is this. And I apologize if this is going to be a little bit violent. Okay. I punch you in the gut. Okay, sinapak kita sa tiyan. The power of my punch, or the power of how hard I punch, is the beta. Right? But the amount of pain that I inflict, or the amount of pain that you feel, that's the significance. So no matter how hard I punch, kung hindi ka naman masasaktan, okay, physically masasaktan, okay, if you're not gonna be physically hurt, then my punch is useless. So in the same way, that if there will be times that you may have a high beta, but you have a low, like you have a not so good significance value. Okay? At the same time then, you may have a low beta, but it's significant. Let's say, pinitik naman kita. Pero, depende kung saan kita pinitik, kung saan mas masakit. Diba? Sa lalaki, alam nyo saan pinakamasakit na mapitik, diba? So, yeah. So that's the difference. So that's the difference. You can look at beta as the power, like the degree of the power of of the effect, of the supposed effect or influence. But how the dependent variable is affected by that, you can look at it at the significance. You can interpret it in terms of the significance value. So parang lumalabas din guys, between beta and the significance value, you may want to put more attention to the significance value. Kasi you can look at it also this way, di ba? Mathematically speaking, when you look at standardized beta, it's the degree of change for every 1 unit increase in the independent variable. So for example, for every 1 unit of change of PPE, trust increases, because it's positive, by 0.370. And by 0.370. Okay? Alright, so let's look at the last one. Look at the last one, regression. Again, linear. And let's look at the last one, SEFF. And we'll see an R square of 0.101. Okay. And you have a beta of 0.318. Okay. And a t-value, a significance value of 0.000. So that means this was 0.318, 3 asterisks. Okay. Now, that is only because we are analyzing them individually. Now, let's see what happens if we put all of them together at the same time. Now, there are 2 ways to do it. And there are 2 ways to do it. Now, from simple, we're now proceeding to a more advanced level, which is multiple. Okay, so yan yung difference. Kasi di ba, ang ginawa natin, we're hypothesizing that each one has an individual effect. But remember, in reality, sometimes these different effects can compete for the same dependent variable. In the same way, probably if you're the crush ng bayan, maraming nagpapapansin sa'yo. So it's just a matter of who would be the most influential amongst those people. Okay, so let's see what happens. So sir, how do we do that? Simple. Regression, linear. You put all of these 3 at the same time. Here. Okay. Now I said there are 2 ways to do it. The first thing, okay, I now turn your attention to the method. Okay, the one right below the independence dialog box. So there are many ways to do a multiple regression method. I will teach you the enter and the stepwise method. What's the difference? I'll explain in a bit. So let's look at enter first. So enter, click OK. Oops, I forgot to show you one thing. Linear. One more thing pala you want to see, especially if you're doing multiple regression, is when you look at statistics, click on the R squared change. Yeah, because you're doing multiple now. You'll see why in a little bit. Okay. So here, yung model summary. Okay, yung model summary. Since we are using enter method, what SPSS did is just to put all of the variables at the same time. Put all of the 3 variables at the same time. So you will only see 1 row here. Now look, the R square now changed to 0.183. But also, you have an adjusted R square. Okay, you have an adjusted R square of 1.77. So that would bring me to another criteria here, R squared and adjusted R squared should both be at least 0.10. Okay. Now, sir, sir, bakit merong adjusted R square? In cases wherein you have to compare different models, you want to compare the results, you will compare it by the adjusted R square. It's adjusted for the number of variables. It's adjusted for the number of variables. Yeah. So, yan. So, okay, pasok tayo dyan. F value, pasok pa rin tayo. It's greater than 4. Here's where it gets interesting. Sa coefficients. Notice that when you put them all together now, si CFP, na kanina significant siya, 'di ba? Yung significance value niya is 0.007. Now it becomes 0.125. Alright, now it becomes 1.125. It becomes not significant. So, nangyari, not significant. Okay? Why? This is a reflection. Yeah, this is the part I was telling you. You analyze it from a one-to-one perspective. Yes, the effect can be observable, can be there. But now you're putting them all together, may isang nasasapawan. Yan. This is the one influence is being diminished because of another influence. Yeah, because of another influence, di ba? Di ba? In the same way, again, kung may karibal ka, diba, nakikipag-compete ka for the attention, there will be days wherein your caribal's tactics will overpower yours for that person's attention, or, diba, there will be days that you will be the one at the center of focus. So, yun ang analogy dyan. And notice na rin, okay, notice that the two PPE, PP is 0.287, 3 stars pa rin. And the third one is 0.211, 3 stars pa rin. But also notice that now that we also put them all together, yung kanina, si PPE, prior positive experience, had a higher beta compared to this here. Na-reduce pa yung influence from 337, naging 287 na lang siya. And then, from 381, naging 211 na lang siya. Kasi nag-aaway na sila. Nagko-compete na sila for that influence. So, one of the more useful things about multiple regression is that you can also tell, like, amongst this different group of independent variables, which one of them is more influential. It's more influential when you put them together. Okay. Now, let's confirm. Okay, let's confirm that one by using stepwise. Yeah.
Sir, adjusted R squared.
Both. Well, for this one, both. You have to report both. R squared and adjusted R squared. Yung adjusted R squared, it's really more for comparison purposes lang siya. Not just in terms of number of variables, it's in terms of number of respondents then. Like say for example, if somebody uses the same model, collected another set of data, it produces an R squared. You don't compare it by the R squared, you compare it by the adjusted R squared. So for instance, if I ask you guys to collect data for your group projects and then run the analysis, then we'll compare it to the R squares that I got. But not the R squared, the adjusted R squares. And see whether your data can be comparable to mine when we do that. So it just gives you a basis whether, it would also tell you whether the data is more fit or less fit compared to the one already collected. Okay, so let's go back to linear and let's look at stepwise method naman. Okay. And then you'll see the difference. Okay. Stepwise method. In this case, what stepwise method does, it analyzes the effects of each individual independent variable, calculates which is the most influential, and then automatically drops from the equation the non-influential one. Because normally, when you see this model summary and you're using stepwise regression, the number of rows or the number of models that you would see here would correspond to the number of independent variables that you put in. However, you notice that there's only two. Then you also note it's only two. Here. So anong nangyari? There was one variable that was dropped. Why? Because it was not significant. Okay. So ano yung not significant na yon? True enough, it's CFP. Diba? Ang natira na lang, di ba? Tingnan nyo yung coefficients table, ang natira na lang is PPE and SEF. Now, this is a more descriptive, a more detailed way of showing you guys yung kung paano sila nag-aaway do sa influence. Or how are they sharing the influence. Since you're using stepwise, what SPSS did is at the first step, si MPPE was put into the model. Why? Because it was simply the most influential out of the three. And then it tried looking at it, and it's on the second step. It did naman self-efficacy. And when it introduced self-efficacy into the same model, ang nangyari, 296, from 370 to 296, because SEF has now an influence of 0.216. See, notice that there are slight changes. Notice that there are slight changes in the beta values. But again, what's more important to us would be the significance values. Of course, it will be a more interesting story for you if the significance values will also change along the way. Okay? If these would also change along the way. Na, ibig sabihin na talagang may nang-agaw. May nang-aagaw talaga. No, dito, here you see medyo konti pa yung pag-aagawan nila eh. Konti pa yung pag-aagawan nila. But here, you would notice na, once these would change, now, then there will be more sharing or competing that's happening amongst your different independent variables. Now, pro tip. Not just because you ended up with a variable na not significant doesn't mean it's already a bad result for you. It might be the case that you are looking for a variable. You're trying to prove that the variable does not have an influence over this dependent variable. Pwede yun. Pwede yun. Yeah. It's always a sickness, I would say, that people are so obsessed of getting good p-values or good beta values or even good r-squares. Not the case. Not always the case. Mind you, I had a paper published. Out of the 5 hypotheses, only 1 was supported. Okay. Only 1 had significant effect. The other 4 did not. I merely said that, wait, it disproves now, or my research gives a contrary view. A contrary view to what's common knowledge. And therefore, it opens up for further discussion. Okay. So I always tell students who are doing statistics, who are doing this kind of research na it's not always, hindi kayo babagsak sa thesis ninyo kapag wala kayong hypothesis na supported. Okay? If your advisor says otherwise, and yes, I'm putting this on record, okay? If your advisor says otherwise, then he or she has something wrong. Okay? Is thinking it wrong. And that's the nature of your data eh. Yeah, that's the nature. In this case, di ba? Okay, I will tell you. Traditionally speaking, in my field of privacy, trust and privacy, concern for privacy towards trust is always has a significant relationship. Okay, negative pa nga. There always has to be a negative relationship between concern for privacy and trust. My data says otherwise. Okay, what would I then in that case? What would I say? Okay, what would I say? What's the implication? It's concern for privacy is not simply is not a cause, is not an influencing variable towards trust. So it might be something else. What is that something else? It's self-efficacy, okay, it's self-efficacy and prior positive experience. So yun yung ano doon, yun din yung practical reasonings na pwede nyo ganun. There's always the case that your data might be contrary to what research has said. Okay? Previous research has said. Theory versus practice. Theory versus reality. So those are the changes that you can also see when you're doing something like this. Okay? All right. Any questions at this point? Any question? Yes.
Sir, ang pagkakakuli ka na yung stepwise is basically the enter method done twice.
No. In enter method is just like putting it all together at the same time. In stepwise, you have three. Let's say you have three variables here. It puts it one at a time. It puts one, runs the regression, and then okay, it sees the result. Puts the second one, and then it tests whether it's still significant. It's still significant, and then if it is, then it runs it again. Then it puts a third one. If it's not significant, then it will stop there.
So when po ginagamit yung enter, are you
it depends on your research question. If your research question would be dealing more about probably like how do different independent variables compete with each other, or if you want to find out if the introduction of different variables would have an effect on some pre-existing notion of something or bias of something, then that would be the case. Like for instance, let's say, di ba, normally let's say you have a situation wherein you want to determine product feedback on something based on what you see. Let's say a water tumbler. I want you to give feedback on this based on what you see right now. And then I get a certain feedback. All right, fine. And then I run a regression. But what you see is not the only thing that would influence your product evaluation, correct? Your peers, user feedback, other user feedback. Ba? If you know this product inside out, then you look at the product reviews. That could be another influence. Then I can use stepwise to see whether the addition of of user reviews will have an effect on what I saw. Okay? Number three. Your personal biases. You're seeing right now is blue. But what if you don't like blue? You like fuchsia, for instance. Then it would affect the way you would look at the product. So how do I test that? Then I would use stepwise again. But let's say if your question is amongst these different collected variables, which one is the most influential? Then isalpak mo na lang lahat yun sabay-sabay. Mag-enter method ka na lang. You see the difference? Although I might be saying that stepwise is more interesting, okay, it's more interesting rather than more interesting compared to enter method. But yeah, that's the case. Now let me give you an example wherein you would hope that some variable is not significant. Diba? And normally this is when you introduce demographic variables into your model, or what we call control variables. Are you familiar with the concept of control variables? Okay, so these are variables that you put into the model and hope they are not significant or they are not influential. So how do you do that? Okay, how do you do that? Let me introduce to you to another function of regression. You see this next button here? Okay, your next button. Okay, so click on next. And that's where you can put your control variables. Bakit? Usually kasi your control variables would have to be analyzed separately. So let's say for example, I want to see whether gender, age, and education has an effect. Has an effect on trust. So I put them there. Okay. And then I run it. Okay. Oops. Okay. I think I lost my file kasi mukhang gumalaw yung aking... Okay. Hang on. Okay. Okay, so let me close this again and let me open it again. Okay. So yeah, so when you look at control variables, okay, when you look at these control variables, so let me run that again. So CF3 here, all of this here, and then again, since I closed it, I have to do it all again. Then when I click on next, let's say I put this 3 here, right? And let's use stepwise. Okay, so notice now I have 3 here. Okay, here I'm hoping that my gender, education, and age would be not significant. Okay, not significant. That's what I'm hoping for. Okay, but my results say otherwise. Okay, you look at the last table, the third. So you notice again there's some movement when you input the independent variables as I previously illustrated. But at the same time, look now here, when I introduced another set of independent, supposedly variables, gender, age, and education, and I'm hoping that they are not significant. Yes, they are not significant. Why? The t values are less than 1.96. Ito, muntika na. Si age, muntika na siya. And all the significance values are greater than 0.05. So this is an instance wherein you're hoping that your t-value is low and your significance value is high, and therefore it's not satisfying your criteria. Okay? Bakit? Kasi ang nangyayari doon, you have proven that indeed kung ano yung independent variables mo, yun yung significant. Yun yung significant. Yung disposition ng tao or the demographic profile of the person is not since you did not hypothesize for it, or since you are hoping that's not the case. Yes, okay. Thank the Lord. Yes, okay siya. Pumasok siya. Now, going back sa question kanina din sa total variance explain. Okay, sa total variance explain. That's another distraction. The demographic variables can be another distraction that you would not account for, that you cannot account for when you want them to answer this survey. Hindi mo sila kontrolado dun eh. And you're hoping that those biases, those built-in or predefined dispositions will not affect your results too much. Magkakaroon ng effect yon, pero not too much, hopefully. Okay? Okay, any other questions? Okay. Any questions? Okay. All right. So yeah, so basically that's it for regression. Okay. For regression, we do still have a little bit of time, so let me stop the video here.